Hello everyone, I would like to give you an update on the CAM features in CADmeister 2025. This year, CAM focuses on improving machining quality with high quality, automation, and easy to operate. First, we will start with CAM operation improvements, covering 6 key topics that focus on enhancing efficiency, improving machining quality, and making the workflow easier to operate. The first topic of CAM operation is Area Element Hidden Mode. In CADmeister 2025, area lines can be configured to not create lines. The system normally automatically creates area lines after the area is registered. These lines are generated to represent the boundary of the defined area. However, in some cases this can be inconvenient because users may not need these lines for their operation. As a result, they have to delete the lines manually every time after creating the area, which can slow down the workflow. To solve this issue, automatic line creation can now be disabled using the NCUSD settings. Simply copy the code, paste it into the NCUSD file, and save the file. After that, re-register the area to confirm the result. You will see that the area lines are no longer created automatically. As you can see, the lines are now hidden, making the operation cleaner and more efficient.
The second topic in CAM operation is the Group and Layer Lock function. Groups and layers that contain CAD elements used for CAM calculations can now be locked. This helps prevent accidental changes to important geometry during operation. To use this function, open the Group Operation Hierarchy tab, locate the group you want to protect, and then right-click on that group to open the context menu. From there, select the Lock option to apply the lock to that group. After locking it, the circle icon will change to a lock icon, indicating that the group is now protected. Once the group is locked, you can continue working on other elements freely without affecting the locked groups. And if you try to delete the locked group, a warning message will be displayed to prevent unintended changes.
Next is the third topic in CAM operation, Recalculation Confirmation. In the latest version, a confirmation message will now be displayed when a recalculation is performed. In this example, I am re-executing the calculation for a program that was not completed calculation. When the recalculation starts, an error or warning message may appear, and the type of message will vary depending on the process being used.
The fourth topic in CAM operation, Display On-Off by Basic Path Type. With this function, you can turn the display of each basic path type on or off individually. To access this feature, right-click on the toolbar, and you will find the Display On-Off by Basic Path Type option in the menu. When you open this palette, you can easily control the visibility of different path types, which makes it much easier when checking or reviewing toolpaths. This function improves path verification by allowing you to focus on specific toolpaths while temporarily hiding the others, making the checking process more efficient.
The fifth topic in CAM operation, Copy between objects. Process copying is now possible between different objects. To use this function, right-click on the process that you want to copy and select Object to Object Copy from the menu. Next, create or select a process group in the target object. Then right-click and choose Object to Object Paste. After pasting, all processes and their associated settings will be copied to the new object, allowing you to quickly apply the same machining conditions without recreating the process from the beginning.
The last topic in CAM operation, Process Copy and Name Change Improvements. With this improvement, the material information is now automatically updated when copying a process or when changing the process name. This means users no longer need to manually update the material settings after these operations. As a result, the process becomes simpler and faster, helping to reduce the time required to create machining data. Next is the CAMX topic that we have a lot of improvement. The first topic in CAMX, Contour Rough Invalid Cusp Height. In CADmeister 2025, the Contour Rough process now includes the Invalid Cusp Height function. This function allows users to suppress unnecessary toolpaths by specifying a cusp height value, helping to optimize the rough machining process. Here, you can see the stock model after rough machining without using this function. In this case, the machining is performed normally without filtering the remaining cusp height. This is also the toolpath generated without using the invalid cusp height function, so all toolpaths are created based on the standard roughing calculation. The Specify Invalid Cusp Height option can be found in the Material settings, and in this example, the option is currently turned off, meaning the system does not apply any cusp height filtering during toolpath generation. Now, let's look at the result when Specify Invalid Cusp Height is turned on and a value is specified. As you can see, some unnecessary toolpaths are removed, and the overall path becomes shorter and more efficient. This is a comparison between the option turned off and turned on, and you can clearly see the difference in the generated toolpaths.
The second topic of CAMX, Added Path Type. In CADmeister 2025, the pencil path is now available within the concave residual high-quality process. This enhancement allows the system to generate additional finishing paths in areas that require more detailed machining. The pencil toolpath is applied to the concave areas that were left uncut by the reference tool during the previous process. By tracing along these remaining areas, the tool can remove the residual material more precisely.
The third topic of CAMX, Turnaround Point Connection Method. In CADmeister 2025, it is now possible to select the turnaround path at corners, getting users more control over how the tool moves when changing direction. This feature provides two connection types, surfaced and approach and retraction. Each type controls how the tool transitions at the corner area during machining. The following example shows a comparison between these two connection methods, so you can clearly see the difference in the generated toolpaths.
Next is the fourth topic of CAMX, Equal Pitch on Flat Areas. The concave residual high-quality process now includes an equal pitch function. This feature helps improve the consistency of toolpath spacing in certain areas. When this function is enabled, the system generates toolpaths with equal spacing on flat corner areas, resulting in a more uniform machining pattern. Here, you can see a comparison of the results with and without using this function, so you can clearly observe the difference in the generated toolpaths.
The fifth topic of CAMX, Support minus Removal. In CADmeister 2025, many CAMX processes now support negative stock allowance. This means users can specify a minus value for the stock allowance, giving more flexibility when defining machining conditions. With this capability, the system can generate toolpaths that take into account factors such as plate thickness and small gaps between surfaces.
The sixth topic of CAMX, Expand upper and lower height limits of the machining area. In CADmeister 2025, it is now possible to adjust the toolpath output range by expanding the upper and lower height limits of the machining area. This provides greater control over where the toolpaths are generated. You can find this function in the Area Define settings, where you can specify compensation values for the upper and lower height limits of the machining region. By adjusting these limits, users can control the vertical range of the toolpath generation, allowing the calculation to focus only on the necessary machining area. In particular, using the lower limit setting can help reduce the calculation range, which may shorten the overall calculation time during toolpath generation. The last topic of CAMX, Enhancements for Horizontal Area Machining. With this improvement, the process can now automatically detect uncut areas that remain at the corners of the toolpath. Here is a comparison of the toolpaths generated using this function, so you can clearly see the difference.
The blue toolpath shows the modified path, which has been adjusted to eliminate the remaining material at the corners.
Next is the CAM 2D and CAM attribute section, which includes one important improvement.
Helical tap compatible. It is now possible to create toolpaths that support helical tapping using a thread mill. To begin, open CAM Attribute Set Hole Auto to automatically create the machining process. First, select all the surfaces that need to be registered as holes. You can use region selection to quickly select all of them at once. After selecting the surfaces, all the hole areas will be registered automatically. Next, select the assignment table name to define the rule set that will be used for the hole processing. You can also click Edit to review or modify the rule settings. In this example, we are using a rule set for M14 to M26. The name and comment fields can also be checked, which helps users better understand the rule configuration. Next, execute the attribute automation to assign the attributes. And then click Attributes Creation. After that, go to CAM Attribute Deploy to create the machining process group. Right-click and select Edit User Standard if you want to check the contents of the process group. In this case, the hole is assigned with helical tapping using a thread mill 12. This section shows the new helical tapping settings that were added in CADmeister 2025. Now click Execute to generate the process group. This completes the creation of the drilling spiral process using CAM Attribute. Next, I will introduce the drilling spiral function in the CAM 2D settings.
First, the spiral direction can be changed between anti-clockwise and clockwise depending on the machining requirements. Second, the machining direction can be set to either top to bottom or bottom to top. Third, the radial scoring cut performs machining layer by layer, which helps the NC machine run more slowly and stably during the cutting process. Finally, the approach motion can now be changed to a helical approach using a setting, allowing the tool to enter the material more smoothly.
Now we come to FM CAM 2 topic.
Next, let's look at the FM CAM 2 topic, Approach and Exit Edit. In FM CAM 2, you can now use the Approach and Exit Edit function. To access it, open the FM CAM 2 tab and click the function located at the top right. This function automatically adds approach and retract motions to the specified toolpath at the start and end of each pass. By using linear and arc motions, the tool enters and exits the material smoothly, reducing load and improving machining quality. You can also choose the type of approach, retract, and pick feed that you want to use. In addition, you can change the contour type as well.
Finally, the last topic for today's CAM update is CAM structure.
The first topic of CAM structure, create machining part automatically seat wall concave radius support. Now, in CAM structure, it is possible to create machining regions for pocket shapes that include concave fillets. As you can see, the highlight shows that the bottom radius, R, is included in the detected area.
Next, I will show you how to set up this operation step by step. First, define the machining features by using the Convert Machining Feature function. This will recognize the basic geometry as machining features. Next, set machining features for other face colors by using Convert Machining Surface Color to Feature. This helps include additional surfaces based on their color attributes. After that, the Check feature window will pop up, showing the detected area separated by type. You will see that all pocket areas are initially classified as pocket type, and these can be modified as needed. Then, double-click on the subtype field and change the 4 pocket areas to bottom R pocket. This completes the operation to register pocket areas that include a bottom radius, allowing the system to properly recognize and handle these features in the machining process.
The second topic of CAM structure, improved automatic wall connection. Wall surface toolpaths can now be connected even between walls that have different step heights. This is achieved by inserting corner arcs into the virtual wall, which helps create a smoother and more continuous connection between the toolpaths. As a result, the tool can move more naturally between stepped wall surfaces, improving the overall machining flow. You can configure this setting by going to Concave Corner in Wall Correction Details. The final topic of CAM structure is box including seat surface. Seat face areas can now be recognized as rectangular shapes. This allows the system to identify these areas more appropriately depending on the geometry, which can help improve the way the machining area is handled. The setting for this function can be found in Bottom Correction Details. From there, you can now switch between polygon type and rectangular type, depending on the shape you want to apply.
Thank you for watching, and see you again next year.